Hello again. We are up to number 12, which is dealing with means and medians and things of that nature for data sets. I changed the numbers around, just wrote down some random kind of small integer values, because who needs to do decimals in this stuff? Wrote down 9 different numbers. You always kind of want to count them. One of them I didn't give you is the value of k, just like your book did. I changed them usually in stat courses, lowercase n versus uppercase. Lowercase is if you're doing repeated samples from something, got different uses, but sample size is going to be an n. Lots of times uppercase means population. We don't care about it for this. We're treating this as if it's just a population. Who cares? 9 items, median, mean. They give you the mean in your question. They give you a mean of something. I give a mean of 5. I use the Greek letter there. I'm going to go ahead and write down mean. Mean is just what most people refer to as the arithmetic, the average. It's an arithmetic mean. It's what people call the average. And for an average, you just add up the total number of things, 5 plus 1 plus 13, etc., plus k, divide by the total number of measurements or values, which is 9. So if we do this, arithmetic mean, we could write sigma for summation, add up all the x's, divide by n. For us, it's going to be 5 plus 1 plus 13 plus 3 plus 6 plus 1 plus 10 plus 2 plus k. We are going to divide that by the total number of measurements. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9 things. And in your book, they give you a mean of 5. So I'm just going to write down a 5. So you have this equation here, right? You kind of always do all the math you can do and then start undoing the math you can't do when you solve for x or k in this case. So the math I can do, I can add all those numbers there from the 5 through the 2. I can add them together. So I'm going to do that because I might as well. 5 plus 1 is 6, 19, 22, 28, 29, 39, 41 plus k. It is over 9, and that has to equal 5 because the mean is 5 in this case, right? If I'm doing this, my next step, I'd probably be saying, how do I get rid of fractions, right? Well, you get rid of fractions by multiplying by a common denominator, preferably a least common denominator. In this case, we only have one denominator, it's 9, so it has to be the least common denominator. So I'm just going to multiply both sides of the equal sign by the number 9. Over here on this side, the 9's cancel. It's the entire reason why we're doing it. So we are left with 41 plus k equals 45. And then algebraically, we'd subtract 41 from both sides of the equal sign. A lot of times at this stage, I just sort of skip that step and just 4. If you're dealing with K through 8th grade students, you probably want to stress seeing the operation done on both sides. A lot of students, even those students I see in college, a lot of times when it's the little simple stuff, they don't know how they got their answer, even though they just did it to get an answer, and they still just don't know what the process is. So training them early on to write the steps down is probably a good idea. I probably haven't done as much of that as I should. I'm working on a kind of a small board, so a lot of times I skip those little simple steps, but subtract 41 to cancel and added 41. Whatever, we get a k value of 4. So this here is what our k is up there. All right, the question in your book, it asks for the median of your data set. Median is the middle value, right? So to get a middle value, we have to rank them. When we didn't know what the value of k was, it was kind of difficult to rank them because we don't know how, where would k be in that mess? Now it's kind of easy to see. I have 2 1s, so I'm just going to put the 1s here first. 1, comma 1. I have a 2, I have a 3. Before, when I had just a k, I wouldn't know that it goes here, but we now know it's 4, so. I think this is all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have those, excuse me, Allergies have been getting me lately. If I'm looking for the middle value and I have 9 things, and I can kind of see it somewhere in here, but I want the same number of things on the left as I have on the right. That fifth measurement, when I rank them, it leaves 4 things to the left and 4 things to the right. The way you get the median in terms of the measurement, I'm going to call it median position. You take the number of items you have, add 1, divide by 2. You can kind of see that. If I'm holding up 3 fingers, right, we know which one the middle one is, right? 3 fingers, I don't do 3 divided by 2 and get 1.5 because it's not the first and a half finger, it's the second. 3 plus 1 is 4, divided by 2 is 2, whichever way I count. 1, 2, 1, 2. It's the second finger. So for us, it's the 5th measurement, whether I go from small to large or large to small. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Something to notice about these numbers, I gave us the median, but this is something that's important to doing data sets of this nature in general. A lot of times people talk about mean values as if they really kind of are the important one because the average is such and such. But if I make this number 1,300, if I make it like a million, 1.3 million, whatever. If I make that 1 million, right, 1.3 million, our mean has just became shifted to 130,000 because that would now be 1.3 million and this is like 1.3 million and whatever, right? So I just shifted that thing up to 100,000 plus for the mean. The median is still that. When you have outliers, really, really large values or small values, right? They don't shift the median at all. So that middle measurement a lot of times is a better indicator of what's happening with your data set. A lot of times it depends on what you're trying to show, but there's times you want to do a median versus a mean to illustrate things. They both show different things, just be aware. Middle value, average outliers will affect this, they don't affect that. So. And I mentioned that for a reason, and that reason is that I just looked at number 13 and they kind of deal with that a little bit in number 13. So anyway, that was number 12.